In this video, we are going to discuss about the latch design. On completion of this topic, students will be able to explain the latch design, and also they can differentiate between the latch and the flip flop. So in the latch design, first we are going to see about the latches. That is, latches are the digital circuits that can store a single bit of information and hold its value until it is updated by the new input signals. So this can be used in the digital systems as temporary storage elements to store the binary information, and this latches can be implemented using various digital logic circuits such as AND or NOT, NAND and NOR gates. So here this pass transistor latch, it has a pass with the Chinese and low clock head, and it has a cons as VT drop, threshold voltage as drop, and non-restoring, back driving, output noise sensitivity, dynamic and diffusion input. And this latch design, it has a transmission gate which has no threshold voltage drop, and it requires inverted clock. Here it has the inverting buffer which restores, and no back driving. It fixes either the output noise sensitively or diffusion input. So these latches are the basic storage elements that can operate with the signal levels. Also it can be controlled by the clock transition or flip flops. So these latches are level sensitive devices which are useful for the design of the synchronous sequential circuits, and also these latches are the sequential circuits with the two stable states that are sensitive to the input voltage applied, and it does not depend on the clock pulse. So tri-state feedback, it has a static and back driving risk. This static latches are now essential, and this also known as the preset are the clear states which can be used in the two crossed coupled NOR gate or two cross coupled NAND gate. So using under this normal condition, both the inputs remain 0. So it is very essential. You can see from this diagram. And in the case of the buffered input, it fixes the diffusion input, and also it has a non-inverting, and here this has the buffered output as no back driving, and also used in the standard cells. It is very robust. It is very ratherly large and also slow, high clock also loading. And here this is easy to implement, since these latches are the simple digital circuits which can be easily implemented using basic digital logic gates. It consumes very low power, and it consumes less power compared to other sequential circuits, and can operate at the high speeds, making them suitable for the high speed digital systems. Also it is very, in the cost wise, if you see, it is very inexpensive to the manufacturer, and also it can be used in the low cost digital systems. It can be used for the various applications such as digital storage. So data patch, it is smaller and faster and unbuffered input. Flip flop design is used as a pair of the back to back latches. Quiz questions on the latch design. Explain different types of static latches on registers. Thank you.